Unit 1, Lesson 2 is graphical limits. I guess in the past I've done graphical, numerical, and algebraic limits all at the same time. I guess the reason I've split that up is easing into different skills. So hopefully by the end of this you can evaluate limits graphically. And you should also by the end of this, maybe not perfectly, but hopefully perfectly, be able to use the definition of a limit to explain when a limit does or does not exist. So just in my class, and it's good practice in general for College Board, you're always expected to justify when a limit does not exist. So, hey, this limit does not exist because. But if a two-sided limit does exist, you can simply write the value. Today, because I'm trying to get you on board with what that definition of when a limit exists is, I am going to write out justification, but you do not have to. So if you understand what a numerical limit is, the idea of a graphical limit is kind of the same, just instead of substituting in x values, we're going to use x values closer and closer to our target point and see what happens to the y values. We're still doing two-sided limits. I can't really make you, but on here you should just kind of be pointing at the screen. So if we're going to evaluate the limit as x approaches 2 of x squared, if we were doing numerical limits, we would be choosing x coordinates closer and closer to 2 on both sides and substituting those into our function. And we probably even in class have done that. Red on red isn't going to be great. And so the idea is we're starting to the left and right of 2. Right, kind of like that, and we are tracing along the curve with our fingers. So, oh, look at that. As the x values get closer and closer to 2, the y values get closer and closer to whatever that is, and so we happen to know 4. Okay, so let's give an uglier version, or at least something that's not super predictable. X squared is continuous. So limit as x approaches 5 from the left of f. So we're thinking, 4.9, 4.99, 4.999. As we trace along closer and closer to 5, the y values are getting closer and closer to 4. Yeah, there's a closed circle here with a y value of 4, but if you're just jumping to that closed circle, you're skipping over something and you're going to get a couple of these wrong. Oh, I already have them here. Okay, cool. So, like I was saying there, if you're taking a quiz, if you're taking a test, you're going to get some things wrong if you simply look for, hey, the y value. Let's show you. Okay, limit as x approaches 5 from the right of f. We're tracing numbers greater than 5, 5.1, 5.01, things like that. These y values are getting closer and closer to 4. No problem there. So what about the limit as x approaches 5 of f? Well, that's our two-sided limit. The limit as x approaches 5 from the left of f is 4. The limit as x approaches 5 from the right of f is 4. So the two-sided limit is equal to 4. And so down below, the things I've said out loud, limit as x approaches 5 from the left of f is equal to the limit as x approaches 5 from the right of f, and each of those are equal to 4. That's our definition that we're going to be writing when a limit does exist. That's why the two-sided limit exists, because each of the one-sided limits exist and are equal to each other. That's also the cleanest way to write it. Okay, so here's, I suppose, something I was alluding to earlier. If we limit as x approaches 7 from the left of f, as we trace along here, as we put in, I know I'm starting way to the left of 7, but it's just a nice visual, instead of doing like 6.9, 6.99, 6.999. As we trace along here, we can see that the y values are getting closer and closer to -1, and that is the correct limit. If you were doing a numeric limit and you saw don't know. Let's say we had a table, x, f of x. And you put in 6.9 and got, what is that, negative 0.981. And 6.99 and got negative 0.98, or maybe 99213. And 6.999 and got negative 0.9999964. You know, whether you investigated what was happening at 7 or not, you'd be pretty sure, these y values are getting close to negative 1. It doesn't really matter that f of 7 does not exist. So hopefully we're on board now. The limit as x approaches 7 from the right of f is negative 1. Doesn't matter that this graph is missing something at 7. Okay, so what are we supposed to be thinking if we're doing the limit as x approaches 7 of f? Well, we already did. Limit as x approaches 7 from the left of f was negative 1. Limit as x approaches 7 from the right of f is negative 1. And so we're going to say the limit as x approaches 7 of f is negative 1 since, well, that definition of when a two-sided limit exists. Limit as x approaches 7 from the left of f equals limit as x approaches 7 from the right of f, and each of those are equal to 1. So hopefully that makes sense that what I'm doing here is, you know, this negative 1 is the evaluation of that left-hand limit. So we know there's something weird going on for f at 7, and the answer is, well, something you had last year. The word is undefined. There's no y value for f at 7. When we're talking about algebra, something like this where something can't happen, we use the word undefined. With limits, we use the phrase does not exist, which will come up soon. In fact, right now. Okay, so limit as x approaches 0 from the right. And we kind of see these 2 points, but remember, we're supposed to be, well, one's a point, one's an open circle. You're never going to have problems if you don't shortcut. So just think, okay, if I was doing a numeric limit, 0.1, 0.01, 0.001, oh, I'm doing the limit as x approaches 0 from the right of f, that should give us 0. If we're doing limit as x approaches 0 from the left, that's numbers like negative 0.1, negative 0.01, negative 0.001. Limit as x approaches 0 from the left of f is 4. And hopefully you know what's coming. So what's the limit as x approaches 0 from both sides of f? We don't read it that way, but I figure you're watching this to learn, so why not say it all? We would read this as limit as x approaches 0 of f. And our answer is does not exist. Why not? Because the limit as x approaches 0 from the left of f is 4. The limit as x approaches 0 from the right of f is 0. And those two limits are not equal to each other. All right. So now we'll just start off with a two-sided limit. Okay, so the limit as x approaches negative 6 of f. Well, from the left and from the right, the y values approach 1. So we'll just say 1. Hopefully you're thinking, so this is kind of the warning I said at the beginning. If we're doing a two-sided limit and everything exists, just cool, write down the result 1. We don't necessarily have to write down the limit as x approaches negative 6 from the left of f is 1, which is equal to the limit as x approaches negative 6 from the right of f. We could, but just if a limit exists, we're not expecting you to. All right, limit as x approaches 2 of f. Where's 2? Oh. All right, so in this case, even though we're not asked to, I'm expecting you to justify. So the limit as x approaches 2 of f, hopefully you're thinking, does not exist, because the limit as x approaches 2 from the left of f is 2. These y values approach 2 as x approaches 2 from the left. And the limit as x approaches 2 from the right of f is negative 1. Since those two limits aren't equal, the two-sided limit does not exist. Oh, previewing the future here. So the limit as x approaches infinity of f. Infinity is not a number. Infinity is the idea of kind of growing without bound. So what happens to this graph as x gets larger and larger? Well, we see, I guess this graph is going to keep going up and up and up to the right, or at least that's the best information we have. So there are a couple of ways to write this. The best way is does not exist. A limit is the y value that the outputs of a function are approaching as we get closer and closer to that target input. And if this graph grows and grows and grows, it's never going to stop, which means the y values don't approach a number. They just keep growing forever. So does not exist is the best phrase for that. I like to throw on due to unbounded growth, so we're always explaining why. Sometimes you're expected to write infinity, or at least multiple choice, you'll be given infinity, but does not exist is the best answer.